Hi everybody. So we are now going to move into solving triangles that are not right triangles. These are called oblique triangles. And we can use trigonometry to solve even triangles that aren't right triangles, these oblique triangles. And we have two laws. One is called the law of sines and one is called the law of cosines, because one of them has sines in it and one of them has cosines in it. That's why they're called what they're called. So what I want to do first is to give you a very quick little explanation as to how to recognize which of the two laws we need to use. We won't talk about the laws specifically in this video, but we just got to get some basic terminology on sides and angles and how we can determine which of the two laws we can use. So let's draw a triangle right off the bat here. And first I want to remind you about terminology and what kind of symbols we use when we talk about triangles and solving triangles. Typically what's done is we represent the three sides of a triangle by the small letters A, B, and C. As I'm going to tell you repeatedly in these videos in this unit, the letters really don't matter that much, and I don't want you to get hung up on which letter is which. What you do need to know, however, is that the angles are named with the capital case or the uppercase version of the letter that is the opposite side. So if this is side A over here, this is going to be angle capital A. Side B, the opposite side, or excuse me, the opposite side B is the opposite side to angle capital B. And side C would be opposite angle capital C. Probably should make this look like a little C. Let me redo that so it looks like a tiny C rather than a big C. Alright, very little C. How's that? Okay? One thing I want you to notice, and I'll repeat this in other videos too because it'll become important to you, is that the angle letter is the third letter that you have when you look at the two adjacent sides. Let me say that a different way. Between every two adjacent sides, or two sides that make up an angle, the included angle, the angle between them, is the other letter. So the angle between sides A and B, the included angle for sides A and B, is angle C. I'll do this in a different color. The included angle between sides A and C is angle capital B, the other letter. The angle in between, or the included angle between sides C and B, is angle A. Okay? A pretty important relationship to know when we talk about the law of sines and cosines. So getting back to the law of sines and cosines, because that's where we wanted to talk, or that's what we wanted to talk about. It turns out that in order to solve a triangle, and again by solving a triangle we mean that we find all three sides and all three angles, it is important that you know 3 of the 6 pieces of information in that triangle. You need to know 3 of the 6 in order to find the remaining 3 that are unknown. And furthermore, one of those things that you need to know must be a side. And the reason they must be a side, one of them must be as a side, is because you cannot determine or you cannot solve a triangle simply by knowing 3 angles. I'm going to try to see if I can draw something that looks about right. Yeah, I think I did a pretty good job there. There's 2 triangles. You see those 2 triangles? I think you could probably look at that and say that it is possible to draw 2 very different triangles of very different size with the same 3 angles. So, a situation where you know all 3 angles is not going to help you. You cannot solve a triangle knowing 3 angles. In fact, you should have learned from geometry that knowing all 3 angles, or what we call angle, 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 does nothing other than prove that you have 2 similar triangles, which means 2 triangles of the same shape but different sizes. Okay? So there are 5 other situations. You could know, whoops, that's not what I meant to do. erase that real quickly. Okay, let me go back to my marker here. We could know all three sides, or an SSS situation. We know all three sides and we have to find the three angles. We could know two of the sides and the angle in between them, just like the similarly colored items I have up here, like sides A and side B with capital angle C, or with side A and side C with angle B in between them. Two sides and an angle in between them. And in that case, we would have to find the third side and two of the angles. We could also have, let's see, what could we have? We could have angle, side, angle. There's another option. Or we could have angle, angle, side. Now make sure you understand the difference between those two. The difference between those two is that in this third situation, the side we're talking about is in between the two angles. So just as an example, using this triangle above here, if I had angle B and angle A with side C, which is the angle right between them, that's this situation that I'm talking about. Okay? Angle, angle, side would mean two angles and the side that's not between them. Okay? A side that isn't between them. So if we were talking about, again, angles A and B, our angle, angle, side would mean we either have side B, angle, angle, side, or side A, in which case you would have angle, angle, side. There is one more circumstance, and that's angle, oops, excuse me. We don't want to write it that way, as you'll see in a minute. Okay, although it's a good way to remember that we shouldn't write that one that way. SSA. We shouldn't write that backwards. I think you can see what that spells. And like I tell my students, that's probably a good way to remember that one, because there are some special things you need to know about that particular situation. Okay, and in that case, it's two sides and an angle, but unlike this circumstance, this angle is not an angle in between the two sides. So for example, in my triangle above here, I could have side C, side B, and angle C. That would be a situation of side-side angle. Okay? So we've got 5 different possibilities other than the angle, 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 which is the circumstance that we cannot use. Okay? Each of these circumstances has at least one side in it and 2 other pieces of information. So 3 pieces of information including one side. Now, you need to know a little bit about the law of sines in order to determine which is which. I'm just going to tell you this little piece of information without actually giving you the law of sines until another video. The law of sines requires that you know an angle and the side opposite that angle. In order to use the law of sines, let me repeat, you have to have an angle and its opposite side. Okay? That's to use the law of sines. If we can't use the law of sines, we use the law of cosines. And we opt for the law of sines first because it actually is an easier formula to use. So let's take a look at these 3 situations and see if we have an angle and a side opposite it. And if we do, that means we can use the law of sines. I'm going to redraw my triangle. So here's a triangle. Okay, let's look at each one of our situations. So my first situation is side, side, side. So if, let's say I know sides A, B, and C. These are the things I know. The question is, do I know a side and the angle that's opposite that side? And the answer would be no, right? There are no angles. We don't know any angles here. So we can't use the law of sines. So for this one, we are going to have to use the law of cosines. Step number 1. Okay, now let's look at my next situation. SAS. What if I have two sides, let's call them sides A and B, and the angle in between them, angle C? Do I know an angle and a side opposite that angle? And the answer again here is no, we don't. We do not have an angle, or we do not know an angle and a side opposite that angle. So in this case, we are also going to use the law of cosines. Next circumstance, what if I have angle, side, angle? That means I know two angles, I'll call them angles A and B, and the side between them, we'll call it little c. Question is, do I know a side and an angle opposite that side? Now immediately your answer is probably no, right? There is no side with an opposite angle. But if you look closely at this, I hope you can see that if I know two angles in this triangle, A and B, I can pretty easily find the third angle, can't I? Because I know that three angles add up to 180 degrees. So in effect, even though I have to calculate what that third angle is, I do have an angle along with its opposite side that I can use. So in this case, again, or not again, this is the first one where I can actually use the law of sines. Okay? Next, angle, angle, side. Let's say I have angles A again and B, but this time instead of the side in between them, I have this side over here, side A. I hope you can see that automatically we have an angle and its opposite side, which means, again, I can use the law of sines. Last situation, the situation that's going to give us trouble, and not simply because of the way it's spelled, and that's side, side, angle. What if I have, say, sides A, side B, and angle A? That's side, side, angle, isn't it? Okay? Yep. Same situation, isn't it? I have an angle and its opposite side, so in this case I can use the law of sines. So just a quick summary. In order to solve an oblique triangle, or any triangle for that matter, I need three pieces of information. One of them has to be a side. I cannot use angle, angle, angle. I cannot know three angles of a triangle and solve that triangle, because we can have similar triangles like these. Same angles, different sizes. Okay? And in order to use the law of sines, we have to have an angle. We have to know an angle and its opposite side. So these three circumstances, angle, side, angle, a side between two angles, that is, angle, angle, side, where the side is not between the two angles, and side, side, angle, where again the angle is not between the sides. All three of those circumstances we can use the law of sines, and those circumstances where we do not have that situation, where we don't have an angle and its opposite side, we must use the law of cosines. Okay, that's it for determining which law we're going to use. Now let's talk about the laws themselves. Thanks.